Okay, now, this portion, this quickie is going, we can do this for like 10 minutes and then we're going to leave for the weekend. Yes, is everybody excited? Yeah! Okay, all right, excellent. Now, what are some questions that I'll answer? I'm not going to write on the board. I may write on the board, but I don't think it's necessary. Here's one here. It said, you're wondering what that equation said. Are you going to use that? Okay. Well, what that was it said that acceleration equals the, I think it said final velocity minus initial, isn't that what it said?
Over time.
Divided by time. Is that coming up on the video? Yeah. You guys are asleep at the switch here, man. Oh, that came up. Oh, well, so you're not asleep at the switch. Excellent. But that's the equation for acceleration. Now, I can reduce that. I could really reduce that to this. I could say acceleration equals change in velocity over change in time. Or I could just simply say, acceleration equals v over t. Okay, you just plug in and solve, right? What's the equation for velocity or speed? What's that equation?
Distance over time.
Yeah. Exactly. Yeah, those are the two equations you need, yeah. So what else? You have questions? Questions? Yes, sir, you're going to ask me a question, right? Yes, you are.
Sir, Abdullah has a question.
Abdullah.
He has a question.
No, I don't.
You told me what's the, should me the speed of what is the
I never asked you
calculation
anything.
line?
Guys, the film is running. Okay? No questions? You have your books out.
Yeah.
Come on, let's go. You know everything? Chatty.
What did accelerate hit? Did you spell it wrong? Acceleration.
Acceleration. ACCELERATION.
No,
That's an N.
All right, okay, all right. It's not the greatest penmanship, okay? Forgive me, okay? I never learned how to write cursive. Talk about a bunch of critics. You know? Abdullah.
So if you're in a car, right?
If I'm in a car, okay, go ahead.
And the relative point is the road, right?
The reference point is the road.
And you're in the car. Are you still in motion?
Well, is there, in other words, this is a great question. You have to have a change, don't you? I mean, if I'm sitting in a car like this,
How are you driving?
is there any change? Is anything changing? Time is changing. Time is changing. But is distance changing? No. So in other words, let's say time is passing. So let's say velocity equals, did distance change? Did distance change? No.
No.
You're just sitting there, right? So distance is 0 change, and this is 10 seconds. So what is 0 divided by 10? 0. So yeah, that has a velocity, yeah. But you're not moving though. I mean, I don't understand what you mean by that. Your movement is 0 because your change in distance is 0. That's an actual velocity. You can have a velocity of 0. Yes?
But like your whole body is moving. Even like the car, your body is moving with the car. Isn't that also considered as like?
Oh, I see. So in other words, you're sitting in the car and you're driving. Is this what you're saying? All right, I'm sitting in the car like this. This is what when I drive home from school, this is what I look like, you know, from the chest up. Are you ready?
Yeah.
This is what I look like.
You don't move right and left. You don't move right and left. Yeah.
Well, I'm driving straight. I can drive straight, can I? You think what do you think? I'm in the mountains, so I'm driving like this all the way home, like this? No, I'm like this. All right, I'm like this. Am I moving from your perspective? No, but we're moving like, I don't know, what is the, look up right now. How fast does the, may I ask the question? Okay.
It goes really
how fast is the surface of the earth rotating? How fast is it going? It's like 8,000, yes, go ahead. How fast, per hour, how fast is it going? Well, it's going, at the equator, it's going 25,000
23 hours, 56 minutes.
miles.
460 meters per second.
Is that what it is?
Yeah.
That's what it is?
Or roughly 1,000 miles per hour. Yeah.
Okay. Yeah, because it's 25,000 miles at the equator, divided by 24, so it's a little over 1,000 miles an hour, right? Correct?
Yes.
All right, so 1,000 miles an hour. Is that pretty fast?
Yes.
Okay, you ready? All right, I'm going to jump up. So according to that, I'll jump up, and I should end up somewhere in Abu Dhabi, right?
No. You are in Abu Dhabi.
Did I? No. So am I moving right now? Am I moving? Am I stationary?
Yes.
No, I'm not.
No, you're not.
I'm moving almost 1,000 miles an hour. Where do I get 1,000 miles an hour? Because that's divided by 1 day. 24 hours. The Earth at the equator, the Earth is approximately, are we at the equator? No. So we're approximating things, right? Okay? At the equator, the Earth is 25,000 miles around, okay? It rotates once every 24 hours, so 25,000 miles per hour per 24 hours, or roughly 1,000 miles an hour. Is that okay with you guys back there? Is that all right? Are we all right with that? So, are we moving? We're moving very fast. Okay, so, but that's not the answer to your question. It sort of is the answer to your question. So if I'm in a car on 10E going to Dubai, and I'm not driving, I'm just kind of sitting there like this. This is what I look like when I'm in the passenger seat. Do, 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 do. I'm just kind of grooving. I'm going. There's a tune. I'm dancing mentally. This is mental dancing. I'm in there. Got a tune. I'm dancing. Okay. Do, do. Okay. So, am I moving relative to the car? Am I moving?
No.
No. Relative to the road, am I moving?
Yes.
Yes, of course I am.
Okay.
Am I moving relative to this classroom right now?
No.
No. Am I moving relative to the earth?
Yes.
Yes.
The earth is spinning around.
Yeah, because the earth is moving 1,000 miles an hour.
And you have that from
Are you okay with that?
Yes.
Right? Yes.
So, but if like you're asked just is it moving, not relative to something, which one's the best answer?
What's the question?
If you're asked are you moving or not, right? When you're in a car and you're not, like your body's not moving.
Okay, all right, this is the question. Okay, this is the question. All right, because they can't hear the question. You have a very soft voice, okay? So let me ask the question here. The question is, what's the best answer if you're asked, are you moving? If you're in a car, are you moving?
Yeah.
Well, the answer to that question is, when we first started this unit, what was the very first thing one of the very first things I taught was reference point, wasn't it?
Yes.
So if you're going to talk about motion, what's the first thing you have to really establish? The concept of the reference point. So that's important. So unless you're given a reference point, it's very difficult to give a proper answer. Now, certain times the reference point is understood. If you're out around town, you're talking to people, the reference point is understood. How fast is that car traveling? Well, it means it's understood that the reference point is the road. Okay? But in a physics class, you might be more specific than that. So, you'd say, how fast are you going? If the car's going 60 miles an hour, how fast are you traveling? Well, now you're getting into some gray area where you should have a reference point. Well, relative to the ground, I'm going the same speed as the car. So if the car's going 60 miles an hour or 100 kilometers per hour, I'm going 100 kilometers per hour relative to the road. But relative to the car, how fast am I traveling? 0. Okay? So you have to establish the reference point. That's an excellent question because that reviews literally how we started this chapter. We started chapter so long ago, and we've been talking about this. Look at what we've done. We've talked about strides and free fall and reaction time and acceleration and velocity. We've covered a lot of stuff. This is almost going to be like a midterm exam, right? We've covered a lot of stuff. So that's a great question. Yes, Abdullah.
It's about acceleration. Like no, for like a speed for a graph, speed versus time graph.
A speed versus time graph. That was the second graph we did.
Right.
We called it a velocity versus time graph.
What happens if it was?
Okay, excuse me, I can't hear. Guys, Abdullah? Okay, I can't hear. Yes.
What happens if it was constant?
Oh, okay. Well, first of all, is velocity constant? Okay, that's a great question, Abdullah. Okay, here's a question. This is a great question. Matter of fact, remind me, I'm gonna have to give you extra credit for this question. This was truly a wonderful question. Okay? This is a great question. Okay. This is his question. This is going to be an informal graph. Is that okay?
Yeah.
Okay. This is time, and this is velocity. Right? Okay. Tell me what's happening in this particular graph. Abdullah. Not anybody else. Abdullah. Okay? What's happening?
It's constant.
What? Yeah, but what's happening? What's going on?
Like you're not changing the speed.
The slope is 0. The acceleration is 0. The velocity, constant. Right? So you're just traveling the same speed. It's a constant velocity. If you have, and then one more thing, and then you're gone. Okay? You right? Right? Let's say I have this. This is D, and that's T. Then what? What's this?
That means you're
What does this mean, guys?
Constant distance.
No. What does it mean?
you're not moving.
Who said that? Chatty?
You said.
No, two people said it. You said it? Abdullah. Yeah, it means that, look guys, this, you know what this means? This means you're standing still.
You're not changing.
You ready? You ready? You ready? You ready? You ready? This, I will demonstrate this graph. Are you ready?
Yes.
You ready?
Well, you're kind of moving. What if?
No. No.
My feet.
Oh.
Have a great weekend, guys.
What if you're moving and football accelerating?
Yeah, I know.
No, that was this. You're moving, this is you're moving and you have constant speed. Okay?
Yeah, I understand.
Okay? Have a great weekend, okay? Nice question, Jessica.